When we think about disasters, we think about things happening here on Earth. Hurricanes, earthquakes, wildfires. Those are terrifying enough. But while you're going about your day, the universe is experiencing catastrophes so massive, so violent, so absolutely destructive that they make every disaster in human history look like a minor inconvenience. And these aren't ancient events. They're happening right now. This very second. As you're reading this, stars are exploding, black holes are tearing matter apart, and entire galaxies are colliding. We just happen to be far enough away that we're safe. For now. Here are 10 cosmic disasters unfolding in space at this exact moment. Starting at number 10, Betelgeuse is having a very bad time. Betelgeuse is one of the brightest stars in our night sky, sitting in the constellation Orion. It's a red supergiant, roughly 700 times larger than our Sun, and it's dying. Astronomers have been watching Betelgeuse closely because all the signs point to it being near the end of its life. In late 2019 and early 2020, it dimmed dramatically, losing more than half its brightness. Something was happening. The star appeared to be shedding massive amounts of material, possibly in preparation for going supernova. When Betelgeuse finally explodes, it will be spectacular. For a few weeks, it will shine as bright as the full moon, visible even during the day. It will be the astronomical event of a lifetime. And it could happen tomorrow, or it could happen in 100,000 years. We have no idea. But here's what we do know. Betelgeuse is unstable right now. It's pulsating irregularly. Its outer layers are being ejected into space. The core is likely fusing heavier and heavier elements in a desperate attempt to stay alive. Every second, Betelgeuse is one step closer to a catastrophic collapse that will end in one of the most violent explosions the universe can produce. It's a ticking time bomb, and we're watching it tick. At number 9, the Andromeda Galaxy is on a collision course with the Milky Way. This one is personal. Our galaxy, the Milky Way, is currently hurtling toward the Andromeda Galaxy at about 250,000 miles per hour. In approximately 4.5 billion years, they will collide. Now, 4.5 billion years sounds like forever, but in cosmic terms, this collision is already underway. The gravitational interaction between the two galaxies has already begun. Dark matter halos are starting to overlap. Outer regions are being stretched and distorted by tidal forces. When the collision happens, it won't be a gentle merger. The two galaxies will pass through each other. Gravitational chaos will throw stars into completely new orbits. Some will be flung out into intergalactic space entirely. Star formation will spike as gas clouds collide and compress. The supermassive black holes at the center of each galaxy will eventually merge, releasing gravitational waves powerful enough to ripple across the universe. Our solar system will likely survive, but it might end up in a completely different part of the merged galaxy. Or it might get ejected entirely, left to drift alone in the void between galaxy clusters. The collision is inevitable. The countdown has already started, and there's absolutely nothing anyone can do to stop it. Number 8 is the ongoing destruction of stars by Sagittarius A*, our galaxy's supermassive black hole. At the center of the Milky Way sits Sagittarius A*, a black hole 4 million times the mass of our Sun, and it's actively feeding. Stars near the galactic center orbit at incredible speeds, and occasionally, one gets too close. When that happens, the black hole's gravity rips the star apart in a process called spaghettification. The star is stretched into a long stream of gas, heated to millions of degrees, and slowly consumed. This is happening right now. Astronomers have observed stars in death spirals around Sagittarius A*. One star, designated S2, passes within 11 billion miles of the black hole every 16 years, traveling at 3% the speed of light at its closest approach. It's only a matter of time before its orbit decays enough that it crosses the point of no return. And it's not just stars. Gas clouds, rogue planets, asteroids, anything that gets too close is shredded and devoured. We've watched gas clouds approach the black hole, get torn apart, and disappear into the event horizon. The black hole doesn't care what it eats. It just eats. Every orbit brings these objects closer. Every pass increases the chance of disaster, and Sagittarius A* just sits there, patient, waiting. At number 7, VY Canis Majoris is ejecting its outer layers into space. VY Canis Majoris is one of the largest known stars in the universe, a red hypergiant so massive that if you placed it where our sun is, its surface would extend past the orbit of Jupiter. And right now, it's tearing itself apart. Hypergiants are incredibly unstable. Their immense size means their outer layers are barely held on by gravity. VY Canis Majoris is shedding mass at an alarming rate, ejecting material into space in massive outflows and eruptions. Astronomers estimate it's losing the equivalent of Earth's mass every year. The star is surrounded by a massive nebula of its own expelled material, proof of the violent convulsions happening on its surface. It's experiencing eruptions so powerful they dwarf anything our sun could produce. Massive ejections of gas and dust are being flung into space at thousands of miles per second. This is the death throes of a star too large to sustain itself. VY Canis Majoris is expected to go supernova relatively soon in astronomical terms, possibly within the next 100,000 years. When it does, the explosion will be visible across the galaxy, but before that happens, we get to watch it slowly self-destruct, piece by piece, in real time. Number 6 is the ongoing collision of the bullet cluster galaxies. About 3.7 billion light-years away, two massive galaxy clusters are colliding at several million miles per hour. We call it the bullet cluster, and it's one of the most violent events ever observed in the universe. When galaxy clusters collide, the galaxies themselves mostly pass through each other because there's so much empty space between stars. But the gas between the galaxies doesn't pass through. It slams together, heats up to tens of millions of degrees, and releases enormous amounts of X-ray radiation. The bullet cluster collision is so energetic that it separated the visible matter from the dark matter. Astronomers can literally see the two types of matter pulled apart by the force of the collision. It's one of the best pieces of evidence we have that dark matter exists. But here's what makes it a disaster. The amount of energy being released is incomprehensible. The collision is generating more energy than billions of supernovas. Everything in that region of space is being bathed in lethal radiation. Any planets, any potential life, anything that might have existed in those galaxy clusters is being sterilized by the sheer violence of the impact. And it's still happening. The collision will continue for millions of years as the clusters slowly merge into one. At number 5, Eta Carinae is preparing for a catastrophic eruption. Eta Carinae is a binary star system containing one of the most massive and luminous stars known to exist. It's a ticking time bomb that has already gone off once and is getting ready to do it again. In the 1840s, Eta Carinae experienced what's called the Great Eruption, an explosion so massive it briefly became the second brightest star in the night sky. The eruption ejected material equal to 10 times the mass of our sun into space, creating the spectacular homunculus nebula that surrounds the star today. The star survived that eruption, barely, and now it's showing signs that something similar might be building again. The system is incredibly unstable, with the two stars in a tight orbit creating chaotic gravitational interactions. Massive amounts of stellar wind are colliding between the two stars, generating X-rays and heating material to millions of degrees. Eta Carinae is expected to go supernova at some point, but before that happens, it might experience more of these massive eruptions, and we have no way to predict when. The next eruption could happen tomorrow. It could happen in 1,000 years, but the conditions are right for it to happen, and when it does, the amount of energy released will be staggering. We're watching a star that has already proven it can produce eruptions powerful enough to rival supernovas, and it's getting ready to do it again. Number 4 is the ongoing merger of NGC 4676, also known as the Mice galaxies. About 290 million light-years away, two spiral galaxies are in the process of destroying each other. They've been orbiting and colliding for hundreds of millions of years, and the gravitational interaction has pulled long tails of stars and gas from each galaxy, giving them the appearance of mice with long tails. These tails stretch for hundreds of thousands of light-years. Each tail contains billions of stars that have been ripped out of their home galaxies and flung into intergalactic space. Many of these stars will never return. They'll drift alone in the void between galaxies forever. Inside the galaxies themselves, chaos reigns. Stars that once had stable orbits are being thrown into random trajectories. Gas clouds are colliding and triggering massive bursts of star formation. The supermassive black holes at the centers of both galaxies are spiraling toward each other, destined to eventually merge in a collision that will shake space-time itself. This is what galactic destruction looks like. It's slow by human standards, unfolding over hundreds of millions of years, but it's absolute carnage on a cosmic scale. And it's happening right now, in real time, frozen for us to observe like a slow-motion car crash. At number 3, the star WR104 is a potential gamma-ray burst aimed directly at Earth. WR104 is a Wolf-Rayet star about 8,000 light-years away. It's massive, unstable, and nearing the end of its life. When it explodes, it will likely produce a gamma-ray burst, one of the most energetic events in the universe. Here's the problem. WR104 is rotating, and its rotational axis appears to be pointed almost directly at Earth. If WR104 goes supernova and produces a gamma-ray burst along its rotational axis, Earth is in the firing line. A gamma-ray burst is a focused beam of radiation so intense it can affect planets thousands of light-years away. If one hit Earth, it would strip away the ozone layer, expose the surface to lethal solar radiation, and potentially cause a mass extinction event. Astronomers debate how precisely aligned WR104 actually is. Some argue the angle is off by enough that we're safe. Others aren't so sure. The uncertainty comes from the difficulty in measuring the exact orientation of a star thousands of light-years away. But here's what we know for certain. WR104 is unstable. It will explode, and when it does, if we're unlucky, Earth could be hit by a blast of radiation powerful enough to end life as we know it. We won't know for sure until it happens, and by then, it will be far too late to do anything about it. At number 2, the Great Red Spot on Jupiter is shrinking and becoming more intense. Jupiter's Great Red Spot is the largest storm in the solar system, a hurricane-like vortex larger than Earth that has raged for at least 400 years. And right now, it's changing in ways that concern planetary scientists. The Great Red Spot is shrinking. Observations over the past century show it's gotten significantly smaller. In the 1800s, it was wide enough to fit 3 Earths across. Now it can barely fit one, but as it shrinks, it's also intensifying. The winds inside the storm are getting faster, the rotation is becoming more violent, and the internal dynamics are shifting in unpredictable ways. Nobody knows what's causing the change or what will happen if the shrinking continues. Will the storm eventually disappear entirely? Will it collapse catastrophically, releasing its energy in a massive planetary-scale event? Will it stabilize at a smaller size? We don't know. What we do know is that Jupiter's atmosphere is in the middle of a dramatic shift. The largest storm in the solar system is undergoing a transformation, and we're watching it happen in real time with no idea how it will end. And finally, at number 1, the Sun is approaching solar maximum, and it's more active than expected. Our Sun operates on an 11-year cycle of activity. Right now, in 2024 and 2025, we're approaching what's called solar maximum, the peak of the current cycle, and this one is shaping up to be more intense than predicted. Solar maximum means more sunspots, more solar flares, and more coronal mass ejections. These are massive eruptions of plasma and magnetic fields hurled into space at millions of miles per hour. When they hit Earth, they can cause geomagnetic storms that disrupt satellites, damage power grids, and interfere with communication systems. In recent months, we've seen some of the strongest solar flares in years. Coronal mass ejections have triggered auroras visible much farther south than usual. Satellites have experienced glitches. Power grids have been put on alert. The Sun is currently unleashing disaster-level energy toward Earth on a regular basis. Most of it is deflected by our magnetic field, but not all of it. A particularly strong coronal mass ejection hitting Earth directly could cause trillions of dollars in damage, knock out power for millions of people, and cripple global communication networks. And the peak hasn't even arrived yet. Solar maximum is expected to continue into 2025. The Sun is building towards something, and we're watching it happen, knowing that at any moment it could unleash a solar storm powerful enough to send modern civilization back to the Dark Ages. 10 disasters, all happening right now. Stars dying, galaxies colliding, black holes consuming everything around them. The universe is not a calm place. It's violent, chaotic, and constantly destroying itself in ways we can barely comprehend. We just happen to live in a quiet corner where, for the moment, things are relatively stable. But space has a way of reminding us that stability is temporary. Every disaster happening out there is a preview of what could happen here, eventually. The universe doesn't care about us. It's too busy tearing itself apart. If this gave you a healthy appreciation for just how lucky we are to be alive right now, hit that subscribe button and turn on notifications so you never miss an upload.